Uh, and yeah, that's basically it, though. You can ask me just software questions, and I'll be presenting some of the robotics concept slides later in the year.
All right, thanks. And I actually messed up. I just started recording it. So if you're just joining us in the recording, we're introducing some of the software trainers who will be teaching you this semester. Osman?
Hey guys, can you guys hear me?
Yep.
Yeah, so my name is Oswin. I'm a third-year CS major. I used to be the RoboNav software lead last year, but now I'm just a regular member for both RoboCup and RoboNav. And my hobbies are robots. It's kind of like boring, but interesting at the same time.
All right, thanks, Oswin. This is me. Hello, everyone. I'm Kyle. I'm a CS major. I forgot to write down the year, but I'm a third year. I'm also doing a math minor. So I have I like the nitty-gritty theory. And then I'm regularly on RoboCup software, as well as being your software training lead for this year. And other than robots, which might be classified as more of an addiction than a hobby at this point, I also play guitar. Woodward?
Hey guys, I'm Matthew Woodward. I graduated from Tech last semester with a degree in computer engineering, and I'm still here doing a EC Masters. So I do RoboCup mostly, and I was previously the RoboCup project manager and the software lead the year before that.
Hello, I'm Matthew. I'm a second-year Comp E major, and I'm going to be a math minor as well. I am the current RoboNav software lead, and my hobbies are robotics and video games. That's about it.
Hey, I'm Hussein. I'm a third-year math major and a CS minor. I'm currently the RoboCup software lead, and some of my hobbies are reading comics, playing strategy games, and playing drums.
Hi, I'm Daniel. I'm a third-year CS major. My fields are device and intelligence. I'm doing the robotics minor. I'm currently the road racing software lead, and some of my hobbies are robotics and tennis, I guess.
All right, so those are all of your trainers for this semester. You'll notice that there are 2 mats. There are actually 3 mats just to make it extra confusing on software training. So the third mat is an alum who will also be helping out from time to time. You may see him around once or twice. Anyway, so if you're here, you know when the meeting time is. We're doing this practical programming sessions, which is going to be sort of an introduction to all the practical aspects of how we work with robots and how we write code for these robots. So we're going to start off with an introduction to C++, and then we're going to move on to something called ROS, which stands for Robot Operating System. The name is a bit of a misnomer. It's not actually an operating system, but we'll get to that. And it's essentially a framework or a library, if you will, that allows you to structure your code, and it gives you a bunch of sort of other libraries that other people have written for working with robots. It's a very, very nice thing to have. It's industry standard, so lots of different things use it. It's also a research standard. Pretty much every research lab in robotics uses it at this point. So it's a very nice thing to know. And then we'll have a little bit more detailed C++ stuff at the end of that. The other session that we're doing is new for this year. It's going to be on robotics fundamentals, and it's aimed at teaching you essentially the basic ideas of many different categories of things in robotics. So we're going to be switching off topics week by week based on sort of what teams thought were the most interesting or the most relevant topics for you guys to know.
Sort of. Essentially, they tried to pull it at a budget session, but then someone was like, no, that doesn't make any sense. And they're like, yeah, it doesn't make any sense. So stop trying to do it.
Jason.
So usually how that kind of works, stuff
Jason.
like that would be written into policies.
I'm just going to mute
which they wouldn't write.
Jason sometimes is in 2 meetings at once. So I don't think that was meant for us. Anyway, robotics, very much lost my train of thought there. So all the topics from robotics fundamentals sessions are going to be things that are really relevant to all the teams. We're going to go over things like motion planning, motion control, vision systems, machine learning, and a couple other topics that are super important and very fundamental to a lot of the algorithms that we write on software teams. So that's something that I'm really excited for this year, because I think it's going to give you guys a better introduction into the world of robotics, apart from just how to write C++ code. Okay, so a few more logistics items. These are all things that I think should have been covered by the email that I sent out a little while ago, but hopefully this is not news to you. The first one should definitely not be news to you. If it's news to you that we're using MS Teams for video conferencing, cool, but we're going to be using MS Teams for video conferencing. We're going to be using GitHub and GitHub Classroom for tracking the assignments that you guys are going to be working on. These are just going to be intended to keep you sort of up to speed with the material and give you a chance to apply what you've learned. It's also going to give you a lot more integration with, or a lot more practice using GitHub, which is something that all of our teams use. It's sort of a Google Docs for code, if you will. Piazza, which I think that a lot of you probably have used as a part of your class at this point, but it's essentially a question and answer system for students in classes. So this is where you're going to go if you have questions about the things that you learned in class, or are stuck or having difficulty at all with things on assignments. And of course, Slack, which hopefully you guys are also already a part of. But Slack is what we use as RoboJackets for text-based communication. So just to be clear, there's a little bit of overlap here between the functionality provided by MS Teams and the functionality provided by Slack. Teams we are only using for video calling, and then of course, you know, the chat during video conferences. Whereas Slack is where we put all of our other text-based communication. General messages will be sent out there as well. In addition, we're also going to be sending things out on the mailing list pretty much after every session. So again, you know, if you're not receiving emails from the mailing list, please contact me on Slack so we can try to get that resolved as soon as possible. All right. So on to a little bit more detailed stuff. Just for background, a lot of you guys said that you knew Java or Python beforehand. So we're going to be not assuming that, but we're going to be providing a lot of like comparisons to Java and Python to try to help that part of the class who's already worked with that a lot. So you don't need to know any of these programming languages, although it will likely help you if you do, because it'll allow you to sort of compare things to what you already know. That said, we're going to be learning C++ in this. So. Finally, a couple more logistical details on assignments before we wrap up the general background section. So we're going to have weekly practical assignments. These are going to help you guys basically integrate the material, make sure that you actually know the material. It can be very good for reinforcing the topics that you learn in class and getting practical experience with that. It's also going to tell us as trainers what we need to be doing better. There are a lot of topics in this that are going to be confusing, and we're going to be going pretty fast. So if you guys ever feel at all confused, please don't hesitate to reach out to one of the trainers or put things on Piazza or attend office hours and talk to us about this, because we really want to make sure, we know that this is going to be a lot of information to take in, and we want to make you guys productive members of RoboJackets, right? So we have a strong vested interest in making sure you guys are not getting confused. So if you have problems, please talk to us. Anyway, that was a bit of a tangent. Assignments are like going to be due. I think it turned off my video, but I'm heavily quote unquoting due here. You will submit in a sense by pushing to GitHub, but there's no lockout dates or anything like that. And we're gonna expect that you turn those in 1 week after the release of the assignment, and we'll sort of be keeping track to make sure you're vaguely following that. If you don't, or if you're falling behind, your sub-team lead may talk to you to make sure you're doing all right with training as a whole. So After that point, we'll release solutions to the previous week's assignments and give the assignments for the next week. Finally, office hours. We are still figuring out dates for this. I think we're going to have those out to you by tonight. So hopefully I'll be able to send you guys office hours dates and times in the link or in the email that I send out after this class period. In general, if you miss a session, so for example, a lot of people had a chemistry test today and had to miss this session, office hours can serve as a replacement for that if you are sort of still needing that discussion. The lectures themselves will be recorded, so you'll be able to watch the lecture section, but there will be a discussion section that's a little bit separate that will, you'll want to go to office hours if you're confused about things and you miss that. In general, if you get stuck on anything or are confused about any topics, or even you just want to chat with some RoboJackets members who have been around for a little while and may have some interesting perspectives on things occasionally, office hours are great for all of those things. Finally, the structure of these classes. So not this week, but after this week, we're going to spend 10 or 15 minutes right at the beginning to go over the previous week's problems and just talk about some things that might have been tricky or confusing. We're also going to have, or after that, the main section of lecture, which is going to hopefully last around 45 minutes. And then we're going to follow that out with 45 minutes of breakout room discussion, which is essentially going to be a chance for you to interact with your team and work with your team, like talk to other new members and the trainers on your team to sort of be able to have that environment where you're a part of the actual team that you're on. So for example, I'll be in, well, other than today, I'll be in the RoboCup breakout room with the rest of the RoboCup new members. The RoboNav new members will go to the RoboNav breakout room and so on. And those breakout rooms, if you look in Teams, you should be able to see them on the channel list over to the side. I think you may have to click like the 3 dots and then do like join a new channel or something like that. Or it might be under hidden channels. Yeah, I think that's what it is, hidden channels. Anyway, does anyone have any questions? I know I went through that sort of fast. Does anyone have any questions about the format of the class in general? Or anything that I've said so far? Either.
Yep. So one out of topic question. I'm trying to find the attendance link. So do you know where I can access it? I know
I put it in the chat. Okay. So if you scroll up in chat, it's only a couple messages behind. Can I pin this message? No, I can't. Oh well. Anyway, it's in the chat. So if you look
for some reason, I'm not able to find it.
The chat for this.
No, just I see a chat is empty for some reason.
You see the chat for this MS Team is empty. Okay.
Yeah.
That sounds like a weird MS Teams issue. That's strange. I haven't seen that before. I'll ping me on Slack and I'll send you the attendance link. That's going to be the
okay. Sure.
process.
Thank you.
That said, just to get a little bit of background, I'm going to make a. I'm not gonna. How do I messed this up? I should have done this beforehand. All right. How many of you guys, and I'm gonna make this a poll. How much of the Codecademy exercises sent out before this meeting did you guys do? And I'll send that out of the poll right now. Hopefully the answer is at least some of it or all of it, but okay. I just sent that poll out on the channel chat. We'll get back to it later. All right, can everyone still see my screen? Hopefully that's a yes.
Yes.
Cool. I'm gonna pull up the, so We had a lot of logistical items to go over today, so I'm sorry about that. But next, we're going to go over some of the stuff that you learned in Codecademy this week. So, sorry, Force a Habit, not RoboCup. So I'm going to pull up the slides for that. Okay. So just as a refresher, you guys should have gone over several of the courses in Codecademy. Should have gone through control flow, which is if statements, or conditionals in general, loops. You should have gone over variables, and I think you should have gone over vectors. Is that correct? Do you guys remember that? All right, cool. Thank you. Yeah, in general, when I ask a question, feel free to either unmute or put it in the chat. Either way is great. Just want some feedback there. All right. So we're going to be going over some of that again, just to reinforce it. I know some of it is probably a lot to take in, so let's go through this. This is probably the first program that you saw, I am going to assume. And it just prints out hello world to the console. If you know any other programming languages, you probably learned, like, this is probably the first program you wrote in any other programming language as well. It's a very simple program. So let's just go over the structure of this really quickly. It's got this include statement. And essentially what this does is allows us to use some functionality that someone has defined elsewhere. We'll get a lot more into what this is and how it actually works a little bit later in next week's session. But for now, essentially, you can think of this as just saying, I want to use something from the module IOStream, right? And in this case, IOStream is the module that contains all functionality for interacting with the console. It's essentially the equivalent of print statements in a lot of other languages, or also like read line statements from a lot of other languages. So from there, we create something called a main function. It's a function called main that may or may not mean something to you at this point in time. We'll go over a more general form of this, or what this actually means, next week as well. But essentially, this is just saying, this is the entry point of my program. This is where we're going to start execution, right? And then everything between these lines is going to be run one after another, essentially. At this point, we get into the actual work that happens with the program, right? This cout operator is a little bit weird. Actually, if you've seen any other programming language, it's super weird. But essentially, it allows you to insert multiple things into, or insert one or multiple things into the console. So, for example, this one prints, this statement here, this cout, prints the string hello world. And it's a string because it is in quotation marks. That effectively makes it a string literal, which means that it's just a bit of text that you want to put out verbatim onto the console. And then it follows that up by just ending the line, so that effectively that's like hitting the enter key and going to a new line. So you can also do that with multiple different items. We'll get into that a little bit later, but you could do std cout and then this little insertion thing, and then some string, and then you could do another insertion and do a different string and print out two strings in a row. All right, and when we run this using what's called the command line, you'll get something like this. So in Codecademy, you probably had to do this, I think, once or twice. And this is essentially showing you that you need to first build the program and then run the program. This may be something that's a little bit different from what you're used to, from if you're, for example, using Python. There are two steps to the process, and we'll go over in detail what those are in a little bit. Anyway, once you run the program, you should just get sort of some output onto the console. Yeah, thank you, Woodward, for answering the chat. But just to go back a second, somebody asked, why is it int main? That's a really good question. The answer is that it has some sort of status code, and the convention defined by your operating system is that you have this status code that if you return 0, that means that the program executed normally. So it didn't have any errors. If it returns something else, that means that it had some errors. And again, we'll get into a lot of this stuff later. So variables, these are things that you're probably very familiar with if you've used any other programming language. The difference that you might not have seen, depending on what your programming language background is that variables in C++ have types as sort of a explicit part of the variable, and that can't change over time. So a variable is just a box where you're putting some data. For example, I can make a box called x, right? And that box has some value, and it can also has some restriction on what values it can have. So that's the type. In this case, it's an int, which means that it can hold any integer type of variable, right? There are several other types. There's doubles, there are strings, there are characters, and there are infinitely many types, actually, because you've got things like vector and vector of string, which we'll get into in a bit. So you can use a variable sort of in this way. So for example, if you wanted to print out the value of x plus 5, you can just do that in the same place that you would normally put that string that we had in that last slide. You can put x plus 5 and it will print out the value of x plus 5. Right. Similarly, and this is something that in which variables are very different from how math works, variable values change. So if you are a mathematician and you see this statement that's on the right here, you're going to say that it makes no sense. If you're a programmer, you're going to say, oh, well, it just changes what is in the box called x. It reads the value of the box called x. It adds 5 to that value, and then it dumps that back into x. Somebody just asked, should we use stdendl? Can't we use or \n? Yes, you can use either. If you know that they both exist, you can use either. There are some very small, subtle differences between them, but for like 99.5% of use cases, it won't matter. Yes, Woodward did give the technical difference. stdendl clears the buffer or flushes the buffer. If you don't know what that means, then it's probably okay to use either. But we usually recommend, when you don't care about performance, just use stdendl. It's more explicit and people are used to it. Doesn't really matter though. Anyway, so this statement is pretty reasonable. If you've seen any programming language before, I think pretty much I think somebody mentioned that they were comfortable using R, and R I think is different. But most mainstream programming languages use this format where you're just assigning with the target on the left side and the value on the right side. So it'll evaluate everything that's on the right side and then dump the result into the target, into the left side. Okay, so let's get into types a little bit more. There were all these types that I mentioned earlier. I think I forgot to mention Boolean. And there are certain operations that are okay to use on each type and certain operations that are not. It's also worth mentioning that the type of your variable can never change. So if I, for example, in this, if I define this integer called x, right? I can never, well, that particular x will always be an integer. You can't later reassign it to a string or make it 5.5 or any of those things. It will always be an integer. And as such, you will only ever be able to do the operations that you expect to be able to do on an integer on that number. And this may sound like it's restricting if you've used something like Python or maybe JavaScript before. It may sound like a restriction, and it is. But long story short, and possibly if you've used either of those languages, you might sort of see this. that restriction ends up being helpful in practice. So here are just some more examples of like inter-language differences. In Python, as mentioned, you don't really have to specify a type for your variable. That's because variables and types aren't like strongly linked. You can change out the type of a variable just by giving it a new value, right? Whereas in C++ and in Java as well, you need to know the type of your variable before you can actually do anything with it, right? And actually, when you tell the computer that that variable exists, you need to know that. By the way, guys, I know you guys have been putting things in chat. Feel free to put things in chat or comment at any time if you do have questions. Okay, so a lot of that is probably review. The next section is substantially less review. So let's get into it. This is probably something that you have not seen quite as much before. So essentially, when you're writing C++ code, there are two phases. You write something that you can read, or at least, in theory, you can read. Once you learn the programming language, you can relatively easily read what's happening in the programming language. The computer understands a bunch of ones and zeros, and you don't want to type in those ones and zeros. So what we have is this program called a compiler that essentially sits between what we write and then what the computer eventually sees. And we do what's called compiling our code. We run it through this compiler, and it tells us anything that's wrong with it that would prevent it from being turned into a program that the computer can actually execute. And then if it doesn't have anything wrong with it, it spits out a binary, it spits out some binary code that represents the program that you're running. That's literally just ones and zeros, right? And the one I have here is, I think, from a Hello World program. I know that because I wrote it. Nobody ever actually understands this. Anyway, once you do that, and this is the important dichotomy between languages like C++ and languages like Python, once you run it through the compiler, you can run the same program lots and lots and lots of times. You only need to recompile the code when you change the code. So this allows you to do a lot of, basically the compiler is able to do a lot of very fancy things that makes your program run a lot faster. So if you've ever heard something like C++ is faster than Python, or Java is faster than Python, or any of those types of comparisons, a lot of the time what they're talking about is this. A lot of the heavy lifting is done up front before the program runs. And then later when you run the program, it's faster. The more important difference than performance for the time being is that the compiler will actually catch a lot of the errors that you might have at compile time, so when you're running the compiler, rather than at runtime, when you're running the program. So again, you just compile whenever you need to change your code, and you can run it arbitrarily many times after that. Let's get into some examples of errors that you might see, because this is going to be a very constant part of your life if you're using any programming language. So a lot of programs won't be accessible, or sorry, won't be, sorry, I looked at the chat and then got off on a tangent. A lot of programs won't be interpretable by the computer, so it won't really understand what you're trying to write. And a lot of this is because there are very strict rules on what constitutes a valid program. So in this case, we're missing a semicolon. If you did the Code Academy lessons, you'll know that you need a semicolon at the end of every statement in your program. In this case, we're missing a semicolon after our declaration of X. So we can't compile this program essentially because it expects the programming language requires that there be a semicolon there, and it gives you some error when you try to compile it. And unfortunately, C++ is notorious for not giving the world's best error messages. So here, the error message for you missing a semicolon, which you'd think would be a pretty obvious error message, is error expected initializer before std, which is not entirely intuitive. So, and more frustratingly, it's on the next line. Just some examples of gotchas you might want to watch out for if you're very confused about your error messages in C++. That said, it does give you the line number, which is at least a good idea of where to start. Okay. A less trivial example. So while you're getting started, a lot of your errors will be just because you don't have the muscle memory, you're forgetting a semicolon or something like that. This is a slightly less trivial type of error that can happen at compile time, which is what happens when your types do not match. So essentially, when you're working with things, right, if you want to, for example, assign something to something else, their types have to either match, or the thing that you're trying to assign has to be convertible into the type of the thing that you're trying to assign to. To put that in more concrete terms, if you're trying to assign a int to a string, so if you're trying to assign the integer literal 5, or the integer number 5 to this string, you're going to have a type error there, right? Because the string and a string, right, which is some text, is not the same thing as a as an integer. Somebody asked if there is a preferred editor. Yeah, the VM has Sublime. A lot of us use different things. Sorry, trying to balance the chat and talking at the same time. Anyway, so those are all errors that can happen at compile time, right? But you can also have errors that you can't catch at compile time. Now, one of those is accessing like a position that's not valid in a vector. If you didn't quite get to vectors in the Codecademy, don't worry, we'll go over those later. But essentially, a vector is just a collection of many different objects of the same type. So anyway, in this case, we're accessing a invalid position in a vector. We're trying to access the 0th position, but there's actually nothing in the vector at all, so we can't access that. And compilation is going to succeed, right? But the actual program is going to fail. And the reason compilation is going to succeed but the program is going to fail is that the compiler doesn't really know. If you look at this second line here where it tries to access that element in the vector, you're not going to know that the vector is empty, right? You know that you have this variable called empty_vec, but you don't actually know from the compiler's point of view that that is empty. So it's not really able to give you an error message there. And then when you actually run it, at that point in time, it actually executes that line of code. It hits that line of code and realizes, oh, there's nothing here for me to access. I need to fail. So that particular case, trying to access something that's out of range in a vector, is going to give you something that looks like this. Just as an aside about runtime and compile time errors, compile time errors may feel like a pain, but they are really nice when they save you runtime errors. It's a lot easier to fix a compile time error in general than a runtime error, and it's easier to fix a runtime error than a bug in your code. That's sort of the hierarchy. So in general, you want to fail as early in the process as you can, because that will make it easier to fix whatever issue you have. All right, so this is just a table of conversions that you can do. So it's possible to, so everything that's green is like a trivial conversion. Everything can convert to itself without doing anything special. You don't need to memorize this. The slides will be posted, but essentially you can't convert to and from a string and really anything else trivially, but you can convert between all the number types pretty much easily. And the only gotcha is that a double, so if you have like 5.5, that'll turn into 5 if you try to assign it to an int. Moving along, this is an example program using these conversions, right? So you can see that 5.5, if you try to convert it to an int, will turn into 5. Okay, this is basically identical to the error we saw earlier, so I'm going to sort of skip past it because we're a little bit late on time. So conditionals. So far, everything in our programming has just sort of executed one statement after another in a very linear fashion, right? We've not really had any complicated, branching. We can't do anything different depending on different conditions, right? In actual programs, you want to do that. That is often the point of a program. So to actually allow us to do that, we're going to introduce conditions. And this is an if statement. It should look relatively similar to if statements in Java. It looks similar to if statements in Python. The differences being, you have to have parentheses around your condition, and you need to have braces around the body of your if statement. And all this is saying is that if the condition inside of these parentheses evaluates to the literal, or evaluates to true, right? If it's 1 or if it's true, then we'll do everything between these braces. So in this case, we're using that to read some input from the user and then let them pass or tell them that they were correct if that's equal to a particular secret number. Okay. So a very common pattern is you might want to do one thing if a literal evaluates true, another thing if it evaluates to false. So you have these two branches where you'll always do one of the two branches. You could write this. That'd be a little bit annoying, but you could write it. C++, it's common enough that C++ and basically every programming language gives you a way to do this just off of hand, right? So that's called else. Cool. Side note here, you can also do else if. This is something that I forgot to write in the slides, but essentially you're going to have if and then else if, which is essentially if you want a condition that happens if the first condition doesn't happen, but another condition does happen. That's equivalent to elif in Python. It's a little bit different in C++, but still fairly similar. All right, moving on. I'm sorry, we have a lot of material to get through. So occasionally you also want to be able to do something like this. And this is, so you might want to double back if your answer was wrong, if the user gave the wrong answer. So you can do this with a loop. And the idea is essentially everything in this body will be repeated for as long as this condition holds true. Right. Does anyone have questions about, sorry, this is another syntax comparison with all of the else ifs and stuff. Does anybody have questions about what we've gone through so far? Okay, cool. Moving on. If we want to repeat something a set number of times or, repeatedly for some number that we know, we can use something called a for loop. Again, probably sounds very familiar. For a lot of you, at least. Yes, Java, by the way, yes, if you know Java, like the syntax for all of these is almost identical to Java. It's very similar syntax. I think Java and C++ have syntax both based on the same language. So a lot of the constructs are identical. Okay. So the idea of for loops is that you want to go through some things, and I leave this abstract a little bit because there are two types of for loops. The sort of vanilla or like the earlier type that was it's been in for longer is something where you're counting from a start number to an end number. So you might want to do something 10 times for 10 different values of a number, iterating from like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. However, another very common thing that you might want to do is iterate through a container, right? So, for example, if you wanted to go through a list, if you had a list that contained the names of all the students in your class, you might want to go through that list and do something for each of those students. Is somebody talking, or does somebody have a question? All right, I'll assume that's no. So for loop has 3 separate clauses. It's got this first one, which declares the variable that you're using for the counter, right? It checks this condition every time before it goes through the iteration, and it only keeps going if it's true. And then it does something after each iteration. And usually this something is basically just moving on to the next iteration. It's whatever you need to do that. So in this case, we're declaring this variable called I. We're going to run this loop until I is equal to or greater than 100, right? So we're going to stop when it's equal to 100. And then each time we're going to increment I, we're going to add 1 to I. And of course, this is just going to print out, you know, got 0, got 1, got 2, got 3, and so on until got 99. And you can see that might work, how that might work. All right. So this is just a summary of what that looks like in all of the programming languages that you guys said were, or in some of the most common programming languages that you guys said you're familiar with. In general, C++ is like almost identical to to Java in a lot of its constructs. It's obviously the print statement looks very, very different, but the actual loop itself looks almost identical. They both look very different from Python. And that's because Python uses something called, or uses the equivalent of something called for each, which we will talk about right after we talk about vectors. I know we're jumping a lot around here. So in general, we've talked about how to make a single variable of a particular name, and you could even, or of a particular type, and you could make, you know, a bunch of different variables of the same type if you want. Nothing forbids you from doing that. But if you want to have a arbitrary number of variables, or you want to say have a number of variables that's not known at the time that you compile the code. So in other words, while you're writing the code, you don't know how many variables you have. You're kind of stuck here, right? And that's sort of where vectors come in. So the motivating case there would be like, say you have a program that, I don't know, tracks scores for students in a classroom. I'm very stuck on the classroom metaphor right now because I've been doing a bunch of software training stuff. You might have a vector of the students' scores, right? And you don't just want to like fix and say, okay, I have a variable called Daniel's score, I have a variable called Hussein's score, I have a variable called Kyle's score, and so on for all of the students in the class. You instead just want to have a bunch of scores, right? And that means that you don't have to like add a new variable every time and recompile all of your code every time you want to add a new student to the class, which would be kind of ridiculous. So what a vector does is it just gives you this contiguous block of elements, essentially, right? Where you can add or remove things to this vector, right? Something to note is that a vector has a particular type. So the syntax looks a little bit weird, probably, in that it at least doesn't look like any of the types that we've seen before, right? So we have std vector. Everything that starts with std means that it comes from C++'s standard library, the stuff that you can use no matter what. But then you see these weird angle brackets, and essentially what those mean, or less than greater than signs, is what you might see them as. But essentially what that means is that the type that's listed between those is just a indication of what type of variable goes in each of the boxes here. So yes, this is identical to, or not identical, but very similar to how a list works in Python. The difference between this and a list in Python, a lot like the difference between variables in Python and C++, is that in Python, a list can have, like you could have a list that has a string, an integer, and a double all in the same list. In C++, in a vector at least, all of your items in that vector have to be the same type. And that allows you to guarantee that anything that you're using, like if you're working with all of the items in the vector, you can, you're able to sort of guarantee that you know what you're working with. So somebody asked a question, which is actually a very good question. How do you implement a dictionary or a list that has multiple types of values? So Woodward gave a terse response, but I'm going to elaborate a little bit. In C++, you don't, which is actually correct. There are pretty much no use cases where you actually want multiple types, right? And that's because if you think about it, a vector is, or any list, right, is supposed to have some sort of structure to it, right? Even in Python, when you have this, it's sort of an anti-pattern in that you don't want to have it, and it makes your code needlessly complicated. So, for example, basically all of the things in the same list you should be able to access them as if they're all as if they're equivalent, or as if they in the same way, right? So you don't want a list that has, for example, that is able to have a string and an integer, right? Because at compile time, we need to know what operations we can do on elements of that list, right? So that's equivalent to saying when we write the code, we want to know exactly what we are able to do and what we are not able to do with the elements of that list. If you were able to put different things of different types in the same vector, you would essentially be breaking that. You would not be able to check that all of your operations were legal ahead of time, and you would essentially go to a system where things aren't static, where you don't know what things are happening. So yes, if you try to add for example, if you try to put a string into a vector of int, right, you will have a compile error. And that's generally considered to be a good thing, because it means that you're catching that error now rather than catching it when you run your code and realizing that you're trying to add a string to an integer and you're crashing, right? So yeah, that's going to compile error. Okay, I've actually been over all of this at this point, but the gist of it is that it's an ordered collection of variables, and you can have as many variables as you want within limit. Now, if I try to ask my computer for 400 billion strings, it's probably going to cry at me because I don't have that much memory. But within reason, if I ask for 2 million integers, the compiler will be able to give that to, or sorry, not the compiler, the runtime will be able to give that to me, and I'll be able to create a vector that has that many elements. So a key distinction here is that the size of the vector is determined or exists at runtime, but does not necessarily, or is not determined at compile time. Food for thought there. Anyway, you're also able to index into it. So, for example, you can find the 0th element of the vector. You can find the 6th element of the vector if there are at least 7 elements, and so on. The big gotcha here, and this is the same for most programming languages, but it's 0 indexed. So if I have a vector with 7 elements, for example, with size 7, the last item in that vector is going to be at the 6th index. Where did somebody asked, what is dereferencing a pointer? I hope I didn't put that somewhere, because that is a little bit too soon for that. Okay. Moving. Hopefully I didn't write dereferencing a pointer anywhere. Anyway, if you have somebody else asked, can we concatenate vectors? So no, there are no regular, none of the addition operations or anything like that are defined on vector. You can't, for example, add 2 vectors together. However, there are functions that you can call that will concatenate 2 vectors, essentially. They're just a little bit annoying and a little bit verbose. So long story short, yes, you can concatenate vectors, but it's not like A plus B, like it is in Python. Yep, somebody posted the code for it. Okay, so this is just a little bit of an example of zero indexing. So if I try to set the second element to 3, that's going to set this element. You might call that the third element in English, but it turns out that in code it is almost always more reasonable to refer to things by like 0th index being the first element. Did I say? Okay. In addition, we can do what's called pushback. This is identical to append in a lot of other languages. And this just puts it at the end of the array, or of the vector, right? And it adds a new slot for it. So I touched upon this a little bit earlier, but vectors are generic. You can have whatever type of vector you want. You could have vector of int, vector of float, vector of string. You can have a vector of vectors. Any of these are completely valid things to do, and in some cases, all of them can be reasonable things to do. Somebody asks, what is the difference between a vector and an array? So the short answer is that we haven't covered arrays yet. The long answer is that arrays are fixed size. So you know at compile time what the size of your array is, and you don't know at compile time what the size of your vector is. And that means that the compiler is able to sort of, you may hear me throw around this term static. It's able to statically determine how large the array is. And so it's able to reserve memory for it on what's called the stack. You don't have to care about what that means. All that it means is that it's going to be a lot faster for a lot of purposes. Whereas the vector, yes, as mentioned in the chat, vector is stored on the heap. So yes, vector is identical to array list in Java. And I think I have, okay, I didn't have that. Yes, vector is identical to array list in Java and regular lists in Python. Okay. So this is just a really quick reference sheet on what things vector can do. If you want an actual reference sheet, I would not recommend you use this. I'm going to use this as a opportunity to point out this wonderful website that exists called CPP Reference. I just sent a link to it in chat, specifically to the page on vector. And essentially, this site just contains reference sheets and basically all of the documentation for all of the functions that exist for everything that comes by default in C++. This is very nice. It can also be a little bit difficult to read because there's a lot of stuff on it. But I would try to get used to using it whenever you can, just because it is an invaluable reference whenever you're trying to work with C++. Personally, I use it all the time because C++ has a lot of nooks and crannies that I don't care to memorize. I don't know of someone who doesn't. Okay, you can also iterate over a vector. This is an operation that you can do with it. I'll spare you the suspense. The top one is what it might look like to iterate using sort of the old for loop that we knew about earlier, right? Where you're creating an integer and you're increasing the integer repeatedly. And that allows you until you hit the end of the vector, and that allows you to index into the vector at each element, right? You can do this shorthand because that's so common. C++ introduced this shorthand that lets you do for int I : vec, which basically, or for in general type x : vec. That just allows you to access the elements of the vector directly. Java actually introduced almost identical syntax at one point in time. So it's probably pretty familiar if you've used Java before. And for Python, this is the equivalent of 4x in vec, right? So yeah, hopefully that looked familiar to a lot of you. So here's the little comparison between them. I knew I did have an array list somewhere. Yeah, so one nice thing about C++ over Java, Java has very annoying syntax for creating arrays. So C++ is a little bit terser in that regard. Anyway, that's actually all for the C++ lecture section. I think we're going to go into discussions now. So